So here we have a scatter, so he climbs up this place, and then we let the scatter go, so he will go up on the other side and he will come up on the other side. We can see as he goes up, his speed decreases. As he comes down, the speed increases, and then this thing repeats. You also notice that the scatter from the top, from the left, he slides down and then reaches the top on the other side. This is because there is no friction between the tires and the surface, so there is no thermal energy loss. So we can look for this conservation of energy in this plot in a bar graph. You can see the total energy is same. So when he's coming down, the total energy is constant, always constant. When he reaches the top, his potential energy increases. When he comes down to this valley, his kinetic energy is maximum and it keeps on changing, but the total energy remains the same. The thermal energy here is 0 because there's no friction between his tires and the surface. So we can also see the speed. So speed increases as he comes down. If I turn on the friction here, so let's say if I turn on the friction, if I let this person go, we know in our real life when the person slides down, after some time he comes to the rest. This is because the friction between the tires and the surface, this is because of the friction. So friction is the opposing force on the tires, and due to which there is a heat that releases in when the tires rub with the surface, and this heat is what we call is a thermal energy. Let's check it again. So he slides down, he goes up, but he doesn't go up at the top as previously when there was no friction. He went up to the top on the left. Now he can just when we just let him go from here, let's say from this point, then he does not reach the same point on the other side. So he will slowly come to the rest. This is because we can see from here, this is because of the thermal energy released. So slowly as he comes to the rest, the total thermal energy is equal to the total energy. If I bring this guy up here, we see so total energy is equal to the potential energy from the bar graph. And then if I bring this guy down and let him go, then the potential energy changes because some of that energy is converted into kinetic energy. And we see as he slows down, the thermal energy goes up. So this comes from the friction, and eventually it becomes equal to the total energy. So let's say the total energy of this guy here was some value, and then when he comes to the rest, so all of these potential energy is converted into the thermal energy.